This slide is for class 10. The chapter is triangles. Exercise 6.1 solved. So this is the chapter exercise 6.1 I'm solving here. So let us see the first. Now, you see here, we have to first, before we get into this exercise, let us clear some concepts. The thing is about congruency and similarity. So let us see what is congruency. In lower classes, we have already studied about congruent figures. So what we can say, two figures are said to be congruent if they have identical in every respect. There is no shape and size. Okay? That means identical in every respect means the shape and size must be same and equal. Congruency is always between two figures because when you say congruent, we are comparing two things. Because we are comparing two things, it is always between two figures. And every figure is congruent to itself. So suppose you have the same figure, you can say it is congruent to itself. So now let us see a few of the pictures. Now if you see here, this is a line segment. Now suppose you have another line segment. Okay, see this? A line segment, another line segment, which is exactly overlapping on this first line segment AB, then we say these two are congruent. Okay. Now see this is a circle. Okay. We have another circle overlapping this. So when you have another circle overlapping this, we say these two are congruent. Now see this. This is a triangle. You have one more triangle overlapping this, then it is a congruent. The first triangle was there. Now see this. This is a triangle, right angle triangle. You get one equilateral triangle. They don't have the same shape. Since they don't have the same shape, they are not congruent. This is a rectangle. You have a square over it. They have a different shape, so they are not congruent. See this is a multi-sided figure, polygon. Okay? You have another figure which is inside it of the same shape, but the size is different. Size is different, therefore it is not congruent. That's why I told you it should have the same shape and same size. Shape is same, size is different, so not congruent. The shapes are different, size is same, not congruent. Shapes are different, not congruent. So we start by mentioning it. This is another figure. Now you see another pattern. This was a trapezium, and we compare it with a parallelogram. Parallelogram and trapeziums, they have a different shape, so they are not congruent. Clear? So that means this is congruent. Both the line segments have the same length. This is two circles are congruent because they have the same radius. This figure is not congruent because though the shape is same, size is different. Here the triangles are congruent. These triangles, they have different shapes. So it is not congruent. Here, a trapezium and a parallelogram, they have different shapes. They are not congruent. Here again. So you see here, you get a clear idea as to what is congruency and what is not congruent. I think this could be clear. Now let us see the next thing. What should be the condition for a figure to be congruent? Now let us take one line segment. When you say line segment, what should be the condition? Length of the two line segments must be equal. If the length of the two line segment is equal, then we can say that the line segments are congruent. Now let us take a circle. When you take circle, what about circle? Radius of the two circles must be equal. If the radius is equal, then we can say they are congruent. So because this is in a circle, we have only one parameter, that is radius. Radius determines the size of the circle. So if it is equal, then it is congruent. Now let us take a triangle. In a triangle, corresponding length of the sides of the two triangles must be equal. Corresponding length of the two sides of the triangle must be equal, and corresponding angles of the two triangles must be equal. That means for a triangle, the sides must be equal and the angles also must be. Both the things must be equal. Only then they will be congruent. Now let us see conditions of congruency in general. What exactly in general what we talk about? In general, you can say two figures are congruent if they have the same shape and they have the same size. So now look at this figure. They look same shape. So look at this figure. They have the same shape, same size also. See this. Shapes are different. Shapes are different. They're not congruent. See this. All are stars. They have the same shape. Size is different. So they are not congruent. So what is this? Here they have the same shape and size, so they are congruent. See this? They have the same shape and size, they are congruent. See this? Have same size but different shape, not congruent. Here have the same shape but different size, not congruent. So both the conditions must be satisfied. Only then size is same, shape is different, not congruent. Shape is same, size is not same, so not common. Okay. Now let's go to similarity. Similarity means two figures are similar if they have the same shape and look alike, but their size is different. They should have the same shape. They may look alike. If they are looking alike, then we can say they are similar. Similarity is always between two figures. Again, it's a comparisons. Congruency, similarity, all are comparing between two figures and saying whether it is similar or congruent. Look at the following figures and decide the condition for the figures to be similar. Now see this. We have a line segment. You have one more line. Both are straight in structure, so they have the same shape. The length is different. Okay, so we can say these two are similar. Now let us see, this is a circle. Okay, we have got one more circle which is smaller in size. The two are round in shape, but the radius is different. That means the size is different. So they are similar. Now let us take a triangle. This is a triangle, equilateral triangle. We have one more equilateral. So here both are equilateral triangle, both have the same shape though. So there that means you can say these two are congruent. So congruent figures are also similar because they have the same shape, same size, and everything. Size also same. Not necessarily it should have a different size only. It can have the same size also. That means a congruent figure is also similar. That is why I have taken this example to indicate you that the congruent figure is also similar. Now let us see this triangle. Take this triangle. Now see, look, you can clearly see these two have a different shape. Different shape, but what is the condition? It should have the same shape. So different shape means they are not similar. This is a rectangle. Take a square. Different shape, not similar. See this. Regular polygon. You got another polygon of the same shape. Okay. Shape is same. Size is only different. They are similar. See this. Trapezium. Take a parallelogram. Shape is different, not similar. So now let's start naming it. So I think this could give sufficient picture about what exactly. We need not talk always about a general or regular shapes, that is square, rectangle, triangle, everything. The other things also could be considered. Even then, you can look at the figure and tell whether it is similar or congruent. So that means now let us see what it is. This is similar. What is this? It is similar. What is this? Similar. What is this? Same shape, same size. They are similar. Size is also. So here, shape is same, sizes were different, similar is. If they have the same shape and same size also, they are similar. That's what I, in particular, about this particular example has been taken, showing that even if the size and shape both are same, it will be similar. Here, this shape is different, not similar. Different shape, same size, not similar. Different shape, different size, not similar. Different shape, different size, not similar. Different shape, same size, not similar. Same shape, same size, similar. So this picture could give you a clearly better idea than practically learning a definition. It gives a better idea about what it is. Now let us go further. Now let us see what is the condition of similarity in general. But it should be two figures are similar if they have the same shape. Shape must be same. They are of different size. Size must be different. Okay. If the same shape, different size, then they are similar. Let us show some figures. See this. This is a stamp size photo, and this is the little bigger photo, or that means you can say passport size photo. Both are the figures of the same lady. Who is this lady? Hmm? So if you see these two, they are of the same features, only size is different. They are similar figures. Now let us take another example. See this. This is a bigger size photo and this is a smaller size photo. The picture is the same, only size is different. They are similar. So it is natural in day-to-day life also. We come across number of similar things. We take a small photo, passport size photo, or we take enlarge it and take a bigger size. Both are the pictures of the same person or the same building or same thing. So they all are similar. Now you see, now let us see one more thing. See, this is a ship. It is a model of a ship, small model. In gift centers, you can see, you would have seen such models. Small models are kept and people keep this in the showroom, in the showcase. This is similar to the actual big size ship which is on the sea. It is similar model. It is a model. Its size is in some proportion with the original. If that is 100, this will be 1. 1 is to 100 times. That will be 100 times and this will be 1 time. So it is a model. Therefore, it is similar to the original ship. I take this one. I'll say this. This is a new parliament building. This is how the new parliament building looks. It is the original, are also of the same shape. Only here there is a photograph and it looks small. It is in some ratio with the original, but it is similar to the original. Yeah. Now let us see. This is the town planning, where the roads are laid, where is the building, where is the residential area, where the park should be there. Everything is planned on the sheet of paper. So this is actually a model. You must have seen in some of the buildings also, they keep a model of the building as at the entrance, indicating what is the shape of the original thing. So this is all the things which we come across in similar things. These all are similar things and which we come across in our day-to-day life, and they all are similar figures. Okay, all let us. So all the above are similar to the original things. Okay. This is a building. Original size, it's a big thing, but it is similar to the original. Now, so let us write the definition of similarity. See, both look same, so they are similar. Let's see this. Both look different, so they are not similar. This is a layman's concept about similarity. Looking same, different size, similar. Looking different, maybe of the same size or may not be of the same size. Still, they are not similar. Okay, so let us define it. These are the two triangles, triangle DEF and PQR. They have the same look, same shape. So how will you define it? Triangle DEF and PQR are similar if the corresponding sides are proportional and the corresponding angles are equal. Okay? Both these conditions must be satisfied. Only then we can say the two triangles are similar. So this is definition of similarity in concern with the triangles. Because our chapter is in focusing on triangles, let us see the definition of triangles in terms of similarity. Now, what does corresponding sides of a triangle mean? Corresponding sides, and they are said proportional. So, corresponding sides are proportional means this side divided by this side must be equal to this base length divided by this base length must also be equal to this side, third side upon this side. That means all three ratios must be equal. Then we say they are proportional. And corresponding base with base, side with the left side and right side with the right side ratios are equal. Then we say they are proportional and they are the corresponding sides. Now, next is corresponding angles are equal. That means the angle which is here, this angle should be equal to P. The base angle should be equal to Q and F should be equal to R. All these three angles must be equal. They are equal, sides proportional, then the triangles are similar. Both condition 1 and 2, these two conditions must be satisfied. One without the other will not be similar. If one is satisfied, the other condition is not satisfied, then they won't be similar. Clear? Now let's go to the exercise. Now exercise 6.1. First question is here. What it is? Fill in the blank using the correct word given in the brackets. What is the first question? All circles are dash. Congruent or similar? What it is? Now let's give an explanation. If all circles have the same radius, only then they will be congruent. All circles must have the same radius, then they will be congruent. But in this question, they have not written anything about the radius of the circle. So it is not appropriate to tell it is congruent. But all the circles may have different radius and circles will have the same shape. All circles, when they say everything, they are not specified to a particular radius or anything. So all circles have the same shape, round in shape, but they can have different radius. So they are similar. That means all circles are similar. So your answer should be similar. Okay? Because congruent means they should have mentioned about the radius here. They haven't mentioned anything about the radius. That means the radius could be different. So the correct word for this particular blank is similar. Won't be congruent. Second, all squares are similar, congruent. Now what it be? If all the squares have the same side length, only then they will be congruent. That means they should have the same side length. If they have mentioned it is having the same side length, then we can say it is congruent. But it is not mentioned. All squares. Square length has not been mentioned. So we can say, but it is not necessary that all the squares should have the same side length. They may be different and the squares will have the same shape. So then they will be similar. Because nothing is told about the side length could be different. Therefore, we can say they are similar. So your answer should be similar. Now the third bit. All dashed triangles are similar. Isosceles triangle, equilateral. Which all isosceles triangles are similar or all equilateral triangles are similar? Now let us see. In an equilateral triangle, all the angles are 60 degrees and all the sides are proportional. So the equilateral triangle will be similar. Because whatever may be the size of the equilateral triangle, angle is 60 only. So it will angles are equal and sides maybe 2 times, 3 times, half the size, whatever it is. It's in a particular ratio. So it all triangles will be similar. Then let us see the case what it will be for the isosceles. In an isosceles triangle, all sides may be proportional, but angle may be different. Isosceles triangle, they have said, two sides must be equal, but the angle not necessarily it should be equal. So the isosceles triangle will not be similar for all types of isosceles. So your answer is it should be an equilateral triangle. In equilateral triangle, then it will be similar. Okay. Now let's continue with that exercise. Same first question, and it is the fourth bit. Polygon. Okay. The two polygons of the same number of sides. Number of sides are similar. Two polygons are similar. There will be a number of sides. That means if it's a pentagon, it's a pentagon. It's a hexagon, it's a hexagon. Octagon, it's a octagon. So number of sides is same. Then the corresponding angles are dash and the corresponding sides are dash. Equal and proportional. Now what is the definition of similarity? Sides must be proportional, angles must be equal. So any two figures are similar if and only if the corresponding sides are proportional and the corresponding angles are equal. So that means this corresponding sides are proportional should come here and the corresponding angles are equal should be here and corresponding sides are proportional. Okay, so here first blank, the answer first blank it should be equal and the second blank it should be proportional. Sides are proportional, angles are equal. Clear? Now let's go to question number 2. What is this question 2? Due to different examples of a pair of similar figures and non-similar figures. Okay, we're going 2 examples. So let's take not only just regular figures like a square, rectangle, triangle, parallelogram, rhombus, etc. Let's take some different figures and let's consider both solution. Two similar figures, regular hexagon, hexagon, both are similar. So it will be like this. Both are hexagon and one is small, other is big. Both are similar. So regular hexagon is the example of similar figures. Now let us take another irregular shaped figure having sides proportional and angles equal. Because this should be the condition for the figure to be similar. So if you see this, it will be like this. See, it need not have the same shape. Shape is same, angles are same. Can have anything. It need not be a square, rectangle, anything. So it is a similar figure. Now let us talk about non-similar figures. A square and a pentagon. See the square. Square is this, pentagon is this. They look different. Directly you can say they are not similar. Irregular shape, having different shape and different angles. See this, how it is. Shape, scissor shape. They have a different shape. If you take some measures angles here, they'll be different. So here this doesn't have angles properly. And this has got some angles at least. So it is a non-similar figure. Yeah. This is your third question. State whether the following quadrilaterals are similar or not. These are the figures. These are the two figures which are given. Now, if you see here, 1.5, 1.5, 1. Double is 3, 3, 3, 3. Isn't it? So sides are proportional. So let us see what is the solution. In the above two figures, side lengths are proportional. That is, their side length of the square is twice the side length of the parallelogram. This is a parallelogram. This is a square. The side length is double. Double. Twice it is. 1.5 plus 1.5 is 3. So it is double. So sides are proportional. But see the angles here. These parallel angles are 90, 90, 90, 90. Here the angle is not 90. But the angles are not equal. So since the angles are not equal, so we can say that the above two figures are not similar. Clear? So this was the end of the exercise 6.1. I think you have understood and clear, I think. So if you have any doubt, you can call me and find out. I'll let you help you out. I also conduct classes. So if you have understood the thing, please subscribe and click on the like button. You'll get many more such videos which will be of useful to you. So I think that is, let's close it. Okay. I think it's clear.